We've been looking at week 10 homework question 3, and previous there's a couple of videos. The first one we find the mean of the group data. The second we find the standard deviation of the group data, and it's really involved process. That's kind of older stuff. That's early in the term topics. Now we're kind of getting into the current things. Like we're gonna find the observed and the expected. The observed frequencies is what we're given. The expected, because we're assuming a normal distribution as the null hypothesis, the expected would be just however many we think are going to show up, in that interval. So what we did was let me go to the spreadsheet just to recap just a minute. Okay, so we found the midpoint of each class, and we found the frequency, which in this case in the first class is 21, and then we multiply it by the midpoint. So in that class there's a total of 1134 scores, points or whatever. And then here's the total points, and then you divide that by sample size, and you get the average score. So we found the mean of the group data. And really the trick on that one was just using the class midpoint as the estimator for the values. Okay, and then we found the standard deviation over here. We found the standard deviation. And now it's really starting to look like one of the more recent topics. We need to find, and I want to sketch a little bit, so I have to check the time. I was sketching earlier. Let me start over. That was messy. Okay, so what we have is a distribution, a frequency distribution. And whatever the numbers are, it could look something like this, or just this is just in general, any frequency distribution, maybe it's something like that. And what we want to do is we want to take, in this case, the boundaries, like these are they're going to be the score ranges in our example, like these boundaries, and we want to find, and we've already found in our example, the mean and the standard deviation. So then we can find the z-scores that correspond to the boundaries. And we're assuming normal, like we want the z-scores. Right? So what we're going to do is, the point of all of this is we're going to see how close to a normal distribution it is by getting the expected frequencies. Like instead of the observed, which was on the frequency table, like I think in our first class it was 21. What we're going to do is we're going to get the whole area under the normal curve right here, and that's the proportion of the 200 that is expected, assuming a normal distribution, which is what we did. Okay, so I hope that was helpful. The drawing, it looks messy, but I hope that the explanation that went along with it is going to be useful. Okay, so now we can go ahead and calculate those values. I'm going to look at what the show example does. They go through page after page, like you'll see here. It's just, they take every single boundary, they show the arithmetic, they subtract the mean, divide by standard deviation, they keep doing it over and over again. And then they have a table. What's good for us is we can go straight to Excel and we can get this table. So we'll just take all our boundaries, and I want to copy them and put them over here somewhere. This will work. Okay, we're going to take all our class boundaries, and then we're going to find the z-score that corresponds to one. And I'll show you, I think, the easiest way to do this. It's something with haywire. I don't think it pasted. I think I copied instead of pasted. Okay, I just need that last value, 94.5. I'll just type it. Okay, now we want to know the z-scores. So remember, the z-scores, like these are our input, like our x values, x minus mean divided by standard deviation. Remember, the mean is this 69.2. So we want to calculate this value, and let's do this in this. I'll make some cells a different color so that we can know that this is where our answer is going to be. So yeah, let's make. So we want to calculate x minus mean divided by standard deviation. We've already calculated the mean and the sample standard deviation. So this should be really straightforward. And what's good for us is we're going to let Excel do all the work. So we can just say, in this cell, it's going to be equal to the value minus the mean. And we want this to be a reference cell. The mean is a reference cell, so we can put the $sign in front of the column and the row number. And then we want to divide by the standard deviation, the sample standard deviation that we found. So I want to put parentheses here because we're dividing the whole numerator, x minus mean, divided by the standard deviation. And then we calculated the standard deviation over here. Alright. And then we can get each of these values. Okay, something went haywire. I can fix that. Divide by 0. Oh, okay. We didn't make the standard deviation. I say we. You're probably saying to yourself, what do you mean we? No, I mean I did not make the standard deviation a reference cell, so we got that error message. Okay, I guess we did get it, because we're all in this together, watching the video or whatever. Okay, so that should have a better result. Now we're going to get all the values, all the z-scores, and let's just check them to make sure that we're right. This 1.24 for the boundary, 58.5, it's about negative 1.24. Okay. I think I opened the wrong browser. Give me a minute here to navigate. I don't want to, you probably think I run my mouth all the time like this. If I get quiet when something is going haywire, then not only does the participant who's watching the video think that there's a problem with their computer, they might also think there's a problem with the audio. So I just try and keep talking. But here's our value. You see we get the same values they do without having to show all that arithmetic because we're using Excel. I want to check one more value. Let's make sure that we get 2.932. Okay, good. All right, so we have the z-scores, which is the number of standard deviations away from the mean that our boundaries are. So now we can calculate the area under the curve in each interval. Between each of these z-scores, there's going to be a corresponding area under the normal curve. I'm getting close to this good stopping point because of YouTube time limitations. So let me stop it here, and then we'll pick up and we'll find the expected in each class.